Saxon Algebra 1. This is graphing cubic functions for lesson 115. And first of all, we need to define what a cubic function is. Now, a cubic is usually something that has three, right? We understand what that means. And a polynomial function, polynomials would be, we've been working with trinomials or binomials, but a polynomial function is one that has a cubic function that has a greatest power is 3. Okay, so this would be anything that's cubic. Now let's go ahead and determine the degree of the polynomial determines a lot of the characteristics. So let's look at those characteristics. First of all, this is a linear, and this is a degree of 1. Okay, and we can move this around, but it's always going to be a straight line. It can go left tail down, right tail up, or it can go right tail up and left tail down, or vice versa. It makes no difference. But the ends are always going to go in the opposite direction. Then we move to quadratic. Remember, quadratic is when it's a squared term, so it has a degree of 2 instead of 1. This would be like our x squared plus 2x plus 8. That would be a quadratic because of that 2 as far as the exponent. And quadratic, they go the same direction. Notice that these tails are going up at the same time. Now they can flip over, and we've talked about those that go downward, but they're still quadratic. Cubic goes back to that with the one tail up, one tail down, but it is a curve, okay? And the tails will go in opposite directions. Now, they could go left tail up and right tail down, but it's still going to be a cubic function, okay? The parent function for a cube is y equals x cubed, okay? Y equals x cubed. And then we look at that and we say, well, let's look at it with a negative, and then we'll see what happens. When I make a table and I start plugging in some values, so I say y equals x cubed, and I put in a negative 2 times negative 2 times negative 2, right, is negative 8, and that goes downward. Now notice that what's going on here is when I put a negative value in, I can get a negative output. So a negative input gives me a negative output, because a negative times a negative is a positive, but I'm doing it 3 times, so it's a negative times a negative, which is a negative. And that gives us this left tail that's going downward. Now, when I start plugging these in, I can realize that negative 1 gives me a negative 1, so it still has a curve to it. It's not the difference between these. This is going from negative 2 to negative 1. This went from negative 1 to negative 8 to negative 1, and then it only moved 1 again, and then 1 more, and then 8. So in other words, this curve does occur and has not a straight line like my y equals x parent function, but y equals x cubed is going to do so. Now, what if I threw a negative out in the front there? I think we could summarize that if I threw a negative in the front, it's going to mean that anything that normally would have come out negative is positive, and normally come out positive is negative. And what that means is it's going to take this graph and just flip it over this direction, right? If you watch how that goes. And that flipped over graph causes my left tail to be up and my right tail down. And that would be the negative. Okay? Now, the next thing we're going to look at here is solving by graphing. And our first example shows us x cubed minus 1 by graphing. And when I plug those points in, of course I can take my parent function and just move it down, right? Because that's what that says. It's taking my parent function, moving it down. And I can look and see that it's about the solving by graphing of 0. It would be about right there at the 1 mark approximately. And we can do the same thing with b. Now, I want us to move on to our calculator, and I realize we've had a whole year of these wonderful calculators, and we have not used them for the graphing functions as much as we probably could. But I want us to go ahead and see that I can put in functions like this into the calculator. So if you'll follow along with me, I'll go ahead and move this up just a little bit so that we can. It's going to be a little smaller, but we can see a little more on my calculator and book. And I'm going to go ahead and just make sure that we're all in the same thing. So let me clear my calculator out. And there you can see I have nothing on the screen, and it's completely clear. And so in order to graph this function, I need to first of all put everything on to the same side. So if I look over here, this negative 2x squared needs to move on to the other side, making it 1/2 of x cubed plus 2x squared minus 1, right? 1/2 x cubed plus 2x squared minus 1. And I'm ready to go ahead and put that in my calculator. So I'm going to hit the y equals key, and that's going to open up this right here, this plot line for me to use. And I want to make sure it's 1/2. So I'm going to use the parentheses appropriately and say 1 divided by 2, like that. That's my 1/2, right? Then I'm going to use the X key, all right? And then I'm going to use the raised to. And that raised to is right here. And that means sometimes it's referred to as a caret, raised to the 3rd power, okay? Now, then plus 2x, okay? And I can use my squared key right there, minus 1. Now the next thing I'm ready to do is I'm ready to go ahead and hit my graph key, and what it's going to do is it's going to graph out. Now notice my graph and their graph are the same thing here, and what it's telling me is that their graph is a little bit stretched differently, but it's okay. It gives me the same graph. And the next thing I'm going to do is I want to approximate. So I can use this a couple different ways. And the book has you using the trace function, which means that I'm just going to slide this up and down. And if you'll notice that I could say approximately where it is. And this is by far the easiest, but it's not going to be the best. And if you notice as it's sliding up and down in the lower part of the screen, the X is changing. It's going -1, there it is, less than 1, 0, and going positive. Notice that as it does so, my Y value also changes. Now, if I want to get a little bit more exact with this, I can do so by using this, and I'm going to use second calc. And the book doesn't show you this necessarily in here, but we're going to use the 0 function right here by saying 0, okay? And it's going to ask me the left bound. Now, left bound is the boundary at which it is. Notice my little cursor flashing here. I'm left of this boundary here. So I'm going to hit enter. Yes, I'm okay with that being my left boundary. And then I'm going to just go ahead and make sure I'm to the right of that boundary, or of that intercept. Hit enter again. And notice it gives me these two little arrows at each other. That's my left and right bound. And then it comes up and asks me a question. Do you want to guess on this? And yes, I do like to guess. So I'm going to hit enter on that, right? And when I do so, it's going to say the negative there is at -3.8. Notice where that's at here, -3.8, and I'm going to round that 3.87. This allows me to solve this cubic function where this graph is for this one. Now, if I want to do it again, I'm going to go back over here to hit my second calc again, come down to my 0, and I'm going to make sure that this time I'm to the right of that first one. It says left bound, and then I'm going to move over again to make sure I'm to the right of the right bound, and it says guess, and it's going to give me the next 0, which is -7 or 0.789, and so on. Now, this allows me to actually solve very, very complex problems by using the calculator, just by using those couple of keys.